Lovely. Has everybody got a fresh cup of coffee? Hopefully, because you're in for a treat. We are going to move from what feels like standard, very normal, very maybe not what we're all doing, but what we recognize as support for systematic reviews into a whole new world. And I'm really pleased to have Anna Noel-Storr with us today.
Thank you.
Anna has just get to my right bit of my bit of spiel. Anna joined Cochrane in February 2008 and as an information specialist for the Cochrane Dementia and Cognitive Improvement Group at Oxford University. And she still holds this position, but since 2016 has led the Cochrane Crowd initiative as a crowdsourcing platform where willing contributors can dive into needed tasks aimed at helping identify and describe health evidence. This work has had a major impact on Cochrane's ability to keep up with a deluge of information. Screening is the time suck of so many systematic reviews, and Cochrane Crowd is an amazing new tool. So I'm going to, without further ado, Anna, I'm going to pass over to you so that you can start sharing your screen, and I'm very much looking forward to the talk. Thank you.
Great, thanks very much, and hello everybody. Let me just now try and do this first time without problems. So hopefully you can see my slides. I'm just going to put them into presentation mode now. I do apologize about the bright lights behind me. I should have closed my blinds, but I'll leave them for now. Okay. So Isla, can you just confirm that you can hear me okay and that you can see my first slide on the screen?
Both are perfect.
Wonderful, brilliant. Okay, well, thank you and hello again. So I'm really excited to talk about my experience with crowdsourcing. I work for Cochrane and we produce health evidence in the form of systematic reviews, as I'm sure you all know. We're essentially about trying to find out which treatments work and which ones don't. I'm an information specialist by background, and I've been working in evidence synthesis for just over a decade now. So the problem, well, one problem that I think all information or knowledge brokering organizations like Cochrane face is that our efforts to turn data and information into knowledge and hopefully wisdom are slowed down significantly by the sheer volume of information available. Information that comes in many shapes and sizes and of very variable quality. Another problem or challenge we face in Cochrane is around enabling people who want to contribute, ways in which they can contribute meaningfully, especially people who might be new to the world of evidence-based medicine. Cochrane has a long history of volunteer contribution, but it has traditionally been as an author of a Cochrane review, which brings me to my third challenge, in that we struggle to retain contributors with meaningful ways to remain involved. So undertaking a whole Cochrane systematic review is no small task. It can take a long time to produce a review, and in Cochrane we're committed to updating reviews for as long as needed. So being an author of such a review is no small undertaking, and many do it once and never return. And that seems like such a waste of skills, experience, and expertise. Many would like to stay involved, I'm sure, but not necessarily take on a whole review. So hang on a minute. We've got people wanting to help, and we've got too much information to filter to be able to keep up. So it's clear a new solution is needed, one that makes better use of human effort. And so we built Cochrane Crowd. And in one sentence, Cochrane Crowd is Cochrane's crowdsourcing platform that hosts what we call micro-tasks. So crowdsourcing, just in very brief terms, is the practice of obtaining information or input into a task by enlisting a large number of people, typically via the internet. And there are various different types of crowdsourcing. In Cochrane Crowd, we use a type sometimes referred to as micro-tasking or human intelligence tasking. And so micro-tasking typically involves large data sets that need processing or filtering or categorizing in some way. And the tasks you create require multiple classifications from contributors. And then behind those multiple classifications sits an agreement algorithm. So let's take a look at an example. So we know that systematic reviews are complex, but they are made up of a number of clearly defined activities or tasks. And indeed, many of these activities can be broken down even further into smaller tasks or micro tasks. So take, for example, the activity of study identification for potential inclusion within a review. When we assess a study, we might first assess it based on a title and abstract screening. And if we're only interested in a particular study design, we could create the binary task of, is the record describing the right study design or not? And so one of our main tasks on Cochrane Crowd is the identification of randomized trials. Here's a screenshot of the task panel on Cochrane Crowd. And when the contributor clicks Start, they're presented with a title and an abstract. And they have to determine whether the record is describing a particular type of study, the randomized controlled trial in this instance. So they have 3 decision options: RCT, reject, or unsure. Each task on Cochrane Crowd is supported by task-specific training, guiding the contributor through what it is we're looking for and what should be rejected. And this helps a lot towards ensuring individual contributor accuracy. However, what's really critical for us is collective accuracy. It's getting that collective aggregate final decision and ensuring that that final decision is correct. And so to ensure this, no record is classified or categorized by just one person. In fact, this particular task, records need 4 consecutive but independently made classifications. So for example, if 4 people all classified a record as an RCT, it would be deemed to be an RCT. If 4 people classified the record as not an RCT, so as a reject, the record would be deemed to be not describing or reporting an RCT. If the consecutive chain is broken at any point, the record goes to a particular type of screener in the Cochrane Crowd community called a resolver. And the resolver, who is a highly experienced screener, will make the final decision on the record. All the micro tasks in Cochrane Crowd are about 2 things. They're about identifying a particular type of health research, whether it be a randomized controlled trial or a diagnostic study, and they're about describing that health research. So one of the challenges we face in identifying health evidence is the variability in the way it's been reported. So in Cochrane Crowd, we aim to find it and then describe it in a consistent way using a PICO framework, so that systematic reviewers and others can find the evidence they need with a high degree of precision and specificity without loss of recall or sensitivity. So has it worked? Well, Cochrane Crowd was launched in May 2016, so it's almost 4 years old already. I can't quite believe that. Here are some quite high-level metrics about it. The platform has hosted 40 tasks so far. So some of these are long-term ongoing tasks, like the task to help find RCTs, but others are one-off tasks or pilot tasks. So far, we've just crossed the 4 million individual classifications mark. So that means that there have been 4 million individual classifications made by contributors across those 40 tasks. This equates to around 1 million or over 1 million records, unique records, having been fed into the system and assessed. And we now have a community of over 16,000 people. And those contributors come from over 150 countries. And based on a survey we did a little while ago, we know that most are aged between 26 and 35. Around 50% work in a health-related area. A further 20% are students currently studying in a health-related area. And another 20% currently self-identify as consumers, as we might know, members of the general public who don't have a background in health research. So why do people sign up? Well, I think there are two main motivations. I think people sign up to help produce good health evidence. And as you've just seen, we do attract people who already work and study in health-related areas. But also people sign up to learn. I've put a few short comments up from contributors, and some of these comments also get across the advantage of offering a way of contributing in which they can dive into and dive out of easily and when it suits them. So I like that I can make a small contribution to Cochrane from my home on my own schedule. I hope to be able to contribute as much as I can in college and in my life after graduation, but I like to do something now. And when I saw that I can work directly with Cochrane, I was really excited. And I'll just have to move the comment. I feel like something useful you can do if you just have a few minutes and can't get into something bigger work-wise. It's great being part of the team. It's fun. Honestly, it really is quite fun and is actually useful. So, just to stay a little bit on the area of motivations, I do think that kind of warm, fuzzy feeling is a key part of why Cochrane Crowd has been so successful. You know, people are doing something that is good and something that is contributing to evidence-based medicine. Learning really does play another key role here, because you're learning by doing, and you're gaining a greater understanding of what constitutes a fair experiment, and you'll come across the latest research being done in medicine. But of course, rewards and recognition play a part too. So for example, a couple of years ago, we introduced our milestone badge system as a way of reflecting the progress of contributors. In terms of the quality of the crowd output, probably my most asked question, so in other words, the crowd's accuracy, we've run a number of evaluations to assess collective accuracy. And with each evaluation, we compare the crowd agreement algorithm for that task against a reference standard, the standard way of screening citations, which would usually be 2 people independently screening with a third arbitrating between disagreements. And so we've been able to achieve very high collective accuracy with our agreement algorithms, particularly for the randomized control trial identification tasks. If we look in just a little bit more detail at the randomized control trial identification task, to date, over 62,000 reports of randomized trials have been identified by the crowd. And these were reports that had not been indexed as an RCT in the bibliographic databases. In addition, over 500,000 have been identified as not describing an RCT. And why is that interesting? Well, knowing that something isn't something is still knowing something about it. And with this huge crowd-generated data set of RCTs and not RCTs, we've been able to train a machine to do the task, or at least some of the task. And this has had a huge impact on our ability to scale. So machine learning, in a nutshell, gives computers the ability to learn without being explicitly programmed. And in the context of Cochrane, this is about building classifiers that provide likelihood scores. So with the Cochrane crowd dataset, colleagues we were working with, mainly over at the epicenter, were able to build a machine learning classifier, which we called the RCT classifier. We then used other independent data sets to calibrate the classifier. In other words, to work out where the cut points should be for a machine-derived true positive or true negative. And then a third, again, independent data set to test and validate that calibration. And so for the last 2 years, we've been able to incorporate the RCT classifier into Cochrane's centralized search service. And so in brief, every month we search a range of sources using either sensitive filters or no filters at all. And the records go through the RCT classifier. And records that have a very low probability of describing or reporting an RCT according to the RCT classifier are then discarded with no further action taken on those records. The rest of the records then go to Cochrane Crowd. And on average, the RCT classifier reduces the amount of records that need to go to Cochrane Crowd by somewhere between 65 and 75%. Before we had Cochrane Crowd, so the previous model in place, which was based on a small team of screeners, we were able to handle around sort of 50,000 records per year. In 2016, when we used just the crowd, so no machine learning at that point, the crowd handled around 150,000 records, which was pretty impressive at the time. But when we added the machine into the workflow, we've been able to handle around double that amount for that particular task. And in fact, the machine learning classifier we built for the RCT task, as I say, now handles sort of between 65 and 75% of the records that we import into our system. So the machine in this way acts as a very effective noise reducer, leaving the trickier records for the humans. And of course, the more good quality crowd data we can generate, the more we can keep feeding the machine so that it improves and means that crowd effort can be directed where it's needed most. So I want to talk now just for a minute or two about implementation and impact. So there are two main ways Cochrane Crowd is having an impact. The first is that it's helping to populate and enrich Cochrane's central register of controlled trials. And a recent analysis we carried out showed that our centralized search service processes, which include Cochrane Crowd, are identifying around 97.5% of studies that get included in Cochrane reviews. The second main way is through a new workflow we've developed in Cochrane called Screen for Me. This is where an author team can call on the help of Cochrane Crowd to help identify studies for specific Cochrane reviews. In fact, we have a Screen for Me project live in Cochrane Crowd right now. And how it works is that the crowd are given 2 weeks to screen the search results. And if a crowd contributor screens 250 or more records, they earn named acknowledgement in the review. And so finally, I just wanted to briefly mention what Cochrane Crowd is doing in response to the COVID-19 pandemic. So around 3 weeks ago, we actually launched version 2 of Cochrane Crowd. And then, of course, within days, most of the world went into lockdown mode. We noticed at that point a marked increase in activity on Cochrane Crowd, and I think there were two main reasons for this. I think some people perhaps do have more time on their hands and want to fill it doing useful activities. But second, I think people want to help specifically in the fight against this awful virus. And there are 3 ways we're hoping to be able to help with this. So we've started running weekly 3-hour screening challenges where anyone can hop onto Cochrane Crowd and help find trials. This is really a way of us doing an activity in isolation, but as a community. And we're also soon going to be hosting crowd tasks that are aimed at identifying studies for rapid reviews related to COVID-19. And finally, we're preparing a new crowd task where we will be asking the crowd to help describe study characteristics of studies and trials related to the new coronavirus. So just to end really, we in Cochrane are so incredibly grateful to anyone who finds time to contribute via Cochrane Crowd. I think it's times like these that really make you realize just what a valuable and powerful thing a crowd working towards a shared mission really is. And thank you very much.
Thank you, Anna. That was really, really interesting. And I know a little bit about the crowd, but I think it's hearing the history and having that insight from you was absolutely fantastic. There's even been confirmation from Beverly Hinkson that it's a great fun to take part in a challenge like it. So
oh, good. They are fun. It's bizarre, but they are.
Members of the crowd. So that's great. We have questions as well. We have questions. Just a clarification about the consecutive chain. Is it 4 choices in a row, or is it just 4 choices total that make it an RCT?
Good question. It's 4 choices in a row. That consecutive bit of it's really a key part of trying to eke out as much efficiency as we can. So it's 4 in a row.
4 in a row, fantastic. And are resolvers born or made? How do
Very good
they know who
question.
they are?
Yeah, yeah.
And how do you become a resolver?
Well, with a proven track record of excellence in Cochrane Crowd. So in Cochrane Crowd, everybody starts off at the same level as a normal contributor, we sort of call them. And if you then cross a certain threshold in terms of quantity and quality metrics, you become an expert in the system. And once you become an expert, your decision carries more weight. So that agreement algorithm that I just described about the 4 consecutive decisions actually changes a little bit as you become an expert. If 2 experts see the same record, then it's only their 2 independent decisions that are needed on that record. If it's 1 expert and 2, standard Cochrane Crowd contributors, then it's 1 expert and 2 standard contributor decisions that are needed on a record. Resolvers are then at the next level up from experts. And really that's just based at the moment on my monitoring contributors' accuracy and capacity. We have quite a small team of resolvers. A lot of them are former or current information specialists. Really, they have proved to be the best at the task, but also some that don't have information specialist background particularly, but have really become extremely good at that particular task. And it's task specific. So someone might be a resolver on the task for diagnostic test accuracy studies, but not a resolver on one for another task.
Fantastic. Jane was asking about duplicates. Are the results perfectly deduplicated when they go into the beast, or is there?
We really try to do that, because we are trying very hard to be as efficient as possible, i.e. we don't want people rescreening the same records over and over again. In fact, that's one of the sort of key principles behind Cochrane Crowd, is that to date, within Cochrane, we have worked in a fairly siloed way. We still do in lots of respects, but this is one way in which we are trying to be a little bit more efficient and reduce duplication of effort. And just sort of staying on that point with the Screen for Me workflow, one of the key components within that workflow is exposing already known classifications. So if you have a set of search results that you want to put through the Screen for Me workflow, the first step in that is to run it through what has already been in the system, so that we can surface the decisions that we already have on those records and not get them going through the crowd again. We don't want to sort of waste human effort if we can avoid it.
And there was a couple of points about how students might be signed up to this, or the general principle of encouraging them to take part in this, as opposed to doing potentially a poor systematic review at a point in their studies where they're just not capable of doing it. Is involved in screening a more valuable learning?
I definitely think it's part of a picture, isn't it? It's part of one of many ways in which students and others, wanting to get more into the research side of things and the academic side of things, can gain more experience and build up a bit of a track record of experience and progress in these areas. So one thing we've done with the latest version of Crowd is launch what we call our student pathway. And what this is a set of structured activities within Cochrane Crowd that we think will appeal more to students, that it's open to anyone to try, that takes them through a series of tasks that we have available now on Cochrane Crowd, so that they can try their hand at the RCT task. They can have a go at being part of a Screen for Me project where they get named acknowledgement on a review. They can have a go at the PICO annotation task. We have a couple of also learning only modules on there that introduce them to study design and consort as well. So we're just sort of trying to offer a range of what we call kind of micro activities that hopefully will help people to learn and build up skills and confidence in evidence-based medicine.
Fantastic. Now, there was a question that, because I know nothing about machine learning, I'm just going to read it out. Is this machine learning useful to others? Is it being shared? Now, I presume that there's some sort of code that you can give a machine that will help it.
Yeah, so we've developed, and I want to say I'm not a machine learning person. I did not develop these classifiers myself, but they've been built largely using the Cochrane crowd generated data. Yeah, so we're hoping to make them sort of widely available. They are available in some other software packages already. So I think Epi Reviewer, the RCT classifier is in there, and a couple of other places as well, which I'm happy to post the details of. I think if anyone wants to run their results through the RCT classifier and doesn't necessarily have access to places where it is, then let us know. But yeah, plans are to make it widely available. And I think important to note that with the RCT classifier, and unfortunately I didn't have the right slide on at the time, so I skipped over it a bit, but we went through quite a rigorous process of evaluating it and calibrating it. And that's a really important part when you develop machine learning classifiers, because it's all very well having something that'll give you a likelihood score on a record. What you really need to know is how to interpret that score. What does that mean? Does that mean that anything that gets below a certain score, I can be, 90% confident that it's not what I'm looking for? And, and does that matter? So we've gone through quite a process to make this classifier really sort of implementable. Is that the word? So that you can actually use it in a sensible way. And we're hopefully going to, develop more as we generate more data from the crowd as well. So, for example, diagnostic test accuracy classifiers as well.
Yeah. And Selena in Leicester, presume still in Leicester, I'm making a guess there. Could the crowdsource methodology be replicated elsewhere with a student group or a research group? Because presume that it does use specialist software, highly specialist.
Yeah, I mean, yes, I suppose it. What we've built is pretty specialist. As I say, the principles are pretty straightforward, and I don't see why others wouldn't be able to kind of adopt those principles. So, I think one of the challenges we have is that with each of the tasks we've developed, we've put quite a lot of effort into the training module. So it depends a bit on what tasks it is you're wanting to put to a crowd. We've obviously explored the task of getting a crowd to identify randomized trials to the hilt, and we can give lots of advice about that. And please do get in touch if you have sort of use cases around that scenario. If you are wanting a crowd to help you really identify studies that are for inclusion within a review, whether it's an intervention-based, RCT-based review or not, i.e. you're wanting the crowd to do more of an inclusion criteria-based assessment, that is a much more challenging task. That's essentially a number of what we would call micro tasks all in one, because you're asking them to assess on a number of PICO characteristics. We have quite a lot of experience now of doing that, and we have found that a crowd approach can work very well, but it does mean that you have to get that training right, and you have to get that agreement algorithm in the background right. But very happy to talk and to, if anyone needs any advice or anything.
That's great. Thank you again very, very much. The slides will be going up, the video is going up. I think we answered all the questions, but I'll make sure that they're sent to you so that you can
Brilliant.
If necessary. Thank
Fantastic.
you very much.
Well, thank you.
Much appreciated.
It's been fun. Bye.
See you. So we're just going to have a brief pause in terms of speakers just at the moment, but I thought I would take advantage of this brief pause just to give a shout out for the pair of speakers. Oh, Anna, could you just, oh, great. Is to just give a shout out for the speakers who were not able to join us. In our originally scheduled session, we had 7 speakers lined up. But Linda Ayuku and Paul Levy from NICE, who were part of the original programme, circumstances meant that they were just unable to take part and to join us today. And I quite understand, if you're working for NICE, generating guidelines, you're probably a bit busy with a small disease that's kicking about at the moment. So perfectly understand that they're not able to do it. But I just wanted to highlight the work that they would have talked about, which is the geographic filters that they've developed for the UK to be used within Medline and Embase via Ovid. And clearly this is a UK focus, but it's an interesting topic in itself. Both the filters have been published in Health Information and Libraries Journal last year, and I've used them both, and I highly recommend them. They're scarily comprehensive, which just shows how well it felt that they were very, very good. Linda and Paul have also written an evidence-based library and information practice, that journal, about how to go creating and validating your own geographic search filter. So if the UK ones aren't appropriate or useful to you, then maybe building your own might be an interesting project and challenge. So there's hints and tips, and we'll post up links to all of those papers and all those articles so that you can be either using the UK filters or looking to develop your own, because who doesn't want a project in these times of working from home and all these different challenges? All very good news.